Hello everyone, this is your chemistry class and we have started revision of the chapter number 3, that is elements, compounds and mixtures. And today we are going to revise the topics solution, alloy, suspension, emulsion, then some methods of separation of mixtures. So let's start with solution. A solution is a homogeneous mixture. Now you all are familiar with the homogeneous mixture, the mixture that is mixed well and their particles are not differentiated with each other. That mixture is the homogeneous mixture. So a solution is a homogeneous mixture of two or more substances. The substance that is dissolved, that is called solute, and the substance in which the solute is dissolved is called solvent. Here solute dissolved in solvent, then the resulting that is formed is called the solution. Okay, when solute dissolved in solvent, then after mixing it will get solution, and the solution is a homogeneous mixture. For example, we dissolve sugar in water. We dissolve sugar in water. In this, sugar is a solute. So here this is a sugar. This is a solute. Sugar is a solute and water is a solvent. Mostly water acts as a solvent. Okay. Here sugar is a solute and water is a solvent. After mixing it will give homogeneous mixture, that is called solution. And then our next term is alloy. What is alloy? An alloy is a homogeneous mixture. This is also a homogeneous mixture of two or more metals and a non-metals. Okay, when two or more metals mix with each other, then that will form is called the alloy. It is formed by melting the metals together. When we melt the metals together, then after melting the alloy is formed. Okay, for example, steel is an alloy of iron and carbon. When we mix carbon and iron, then the resulting that is formed is called alloy. That is called alloy, and the alloy is steel here. Okay. Next one is suspension. A suspension is a heterogeneous mixture. What do you mean by heterogeneous mixture? A heterogeneous mixture that is not mixed well. Their particles are differentiated with each other. Okay. So that type of mixture is a suspension. So suspension is a heterogeneous mixture that is containing solid particles called solute. Solid particles called solute and that are not dissolved but get suspended throughout the bulk of the medium. For example, sand in water. Here sand is a solute. This is solid particle. This acts as a solute and water is always act as a solvent. Here sand is act as a solute and water is act as a solvent. When we dissolve this sand into water, then it will not completely mixed with the water, then that will form the heterogeneous mixture. You can look at here. I can mix the salt in water, but after some time it will not dissolve. You can see the sand particles that fall down at the bottom. So it is a heterogeneous mixture in which we have to differentiate about this sand and water. So next is the emulsion. Next one is immersion. Two immiscible. Immiscible means that are not completely mixed with each other. Two immiscible liquids form an emulsion. In most cases, one of the component is water. We already see here that the solvent always act as water. Okay. So next one is the example of emulsion. Like oil in water is an emulsion in which one component that is thicker. The thicker component in emulsion is present in the excess amount. Okay, there are the two components that we have to mix, but the thicker component is present in the excess amount. Then after dissolving they will form a emulsion. For example, face cream. This is a face cream. This is a example of emulsion. The emulsion is a semi-solid. Here you can see this cream is a example of emulsion. This is present in a semi-solid form. Here the thicker part is taken as in the excess amount. So next we will proceed with the separation of mixture. So firstly we will see how separation is done and what is the need of separation to done. Okay, separation can be done due to the following reason. Why separation is done? So we can see here, to remove the undesirable constituents, to obtain desirable substances, and to obtain the highly pure substances. So these are the three main factors due to which we have to do separation of mixture. Like there are many pure substances that are mixed with some unwanted particles and we have only need the pure substances. So there is a need to separate the unwanted substances from the pure substances, so that we have to get only the pure substances. Then the separation process is called purification, in which we have to separate the unwanted particles from the pure substances. That process is called the purification. For example, purification of river water, because we cannot drink the river water directly because it contains many impurities that are unwanted. So firstly we have to purify that river water. After that we have to drink that water. Okay, next example is removing stones from rice. Before cooking the rice we have to remove the stones first. After that we have to cook that rice. So we have to separate the mixtures here. So firstly we have to know about what types of mixtures here that we have to separate. So let's see what are the types of mixture. Then accordingly we have to use some techniques to separate these mixtures. Okay, first type is a solid mixture. First one is a solid mixture. In this the pure substance is also present in the solid form and the impure substance is also present in the solid form. Okay, the substance that we want to get, this also present in the solid form, and the substance that we are not desired to get, that is also in the solid form. Like rice and sand, we desire to get rice but we don't desire to get sand. Dal and rice, then stone and rice, salt and flour. This is the examples of solid mixture. Then next one is a solid liquid mixture. Like solid and liquid mixture. Here the mixture is present solid and liquid combination. Like sugar syrup, salt solution. In salt solution, salt is present in a solid form and water is present in liquid form. Then they will mix to get a salt solution, that is solid liquid mixture. Okay, then starch solution. These are the examples of solid liquid mixture. Then are the liquid mixture, like lemon juice, alcohol and water, oil and water, milk and water. These are the examples of liquid mixture. Next one is a gas solid mixture, in which the mixture contain gas as well as solid particles like smoke and dust particles in air. In air there are smoke and dust particles are present. Then the dust particles are solid and air that is present in the gaseous state. So this is a mixture of gas solid mixture. Next is gas liquid mixture. Aerated drinks like Coke. Coke is a mixture of gas and liquid because it contains gas and liquid both. Oxygen dissolved in water. This is also example of gas liquid mixture. Then is the gas mixture. The gas mixtures are air because air contains many gases. So it is a combination of many gases. So this is the example of gas mixture. Acid vapors in air and water vapors in air. These are also the examples of gas mixture. Here we will discuss about some types of mixtures. Then accordingly we have to use some techniques to separate these mixtures. Okay. Firstly, separating solid mixtures. We have to separate the solid mixtures. For this we have to use sublimation. Sublimation is the technique that we have to use to separate the solid mixture. What do you mean by sublimation here? So firstly we will see what is the sublimation. Sublimation is a change from solid to the vapor state or gaseous state without melting. If we change the solid into vapor state without melting, then that process is called the sublimation. Okay. In this we have to take a mixture of ammonium chloride and salt. These both are in solid form that are taken in china dish. It is covered with funnel. Firstly we have to take ammonium chloride and salt in china dish. Then we have to cover the china dish with funnel. Then the tail of the funnel is plugged with cotton wool. Then we have to plug a cotton wool into the tail of the funnel. Like next, third one is the china dish is heated on a tripod stand. Then in the third step we have to heat the china dish. Then ammonium chloride vaporizes and get deposited near the tail end of the funnel. Then what will happen? After heating, the ammonium chloride vaporize and it will get deposit near the tail end of the funnel. Then salt is left behind in the china dish. In this way we have to separate the salt from ammonium chloride. Okay, let's see here. This is a china dish. Okay, in this china dish there is a mixture of ammonium chloride and salt, and these are taken in the china dish, and this funnel covers the china dish, and the tail of the funnel we have to plug the cotton. Okay, this funnel is in the inverted form. Okay, so what will happen after heating? What will we observe? We observe that ammonium chloride vaporizes and it get deposited at the end of the funnel. So this is the solidified form of ammonium chloride, and the salt is left behind in the china dish. So in this way we have to separate the solid mixture. Okay.